Hello friends. Imagine the day observatories confirm that an asteroid is on a collision course with Earth. Spacefaring nations agree we need to stop it. What happens next depends on how much time the asteroid watchers say we have. In this video we are going to discuss about some scientific ways that may help to stop an asteroid. 1. Kinetic impactor deflection. Kinetic energy is the energy possessed by any moving object. Astronomers believe the same principle could deflect an Earth-bound asteroid. In this case, the cue ball is an unmanned spacecraft similar to the probe used in NASA's Deep Impact mission. The mass of the Deep Impact vessel was only 816 pounds, but it was moving really fast, 5 miles per second. Kinetic energy depends on both the mass and speed of an object, so a small object moving fast still has a lot of energy. When mission engineers slammed the Deep Impact probe into the surface of the Tempel 1 comet in 2005, it was slated to deliver 19 gigajoules of kinetic energy. That's the equivalent of 4.8 tons of TNT, enough to shift the comet ever so slightly in its orbit. Astronomers weren't looking to alter Tempel 1's trajectory, but they know now it could be done, should an asteroid or comet set its sights on Earth. Even with a success under their belt, scientists acknowledge the enormous challenge of such a mission. It's sort of like hitting a speeding cannonball with a speeding bullet. One wrong move, and you could miss your target completely or hit it off-center, causing it to tumble or crack into pieces. In 2005, the European Space Agency came up with the Don Quixote concept to improve the odds of a kinetic impactor mission. 2. Turning the rock into a puffball. You're familiar with puffballs, right? They're the little round mushrooms we often see in fields and forests that reproduce by releasing spores through a topside exit hole. Poke a fresh puffball, and you'll see black smoke shoot out in a jet. Strangely enough, astronomers think they can get an asteroid to do the same thing, though not by poking it. Instead, they envision parking an unmanned probe in orbit around an offending rock, then aiming a laser at the object's surface. As the laser heats up the rocky substrate, steam and other gases will erupt in fast-moving jets. According to Newton's laws of motion, each burst of gas applies a tiny force in the opposite direction. Heat the asteroid long enough, and you'll have it hissing like a tea kettle and moving, centimeter by centimeter, off its original course. Some see the laser as the limiting factor in this scenario. What if it can't draw enough power to sustain long-term heating? You could arm the probe with an array of mirrors. Once you get the spacecraft in orbit around the asteroid, you simply unfurl the mirrors and orient them so that they direct a beam of concentrated sunlight toward the object's surface. This provides the necessary heating without the need for a high-powered laser. 3. Using nuclear weapons. This technique involves slamming a nuclear warhead into an approaching asteroid. There's only one problem: a direct hit on a large object might only break it into several smaller pieces. Remember Deep Impact? A better option might be to detonate a warhead near the asteroid, letting heat from the explosion sear one side of the rock. As material vaporizes from its surface, the asteroid would accelerate in the opposite direction, just enough to steer it away from Earth. So what do you think? With today's technology, is it possible to stop an asteroid? Let me know in the comment section. Thanks for watching, and if you like this video, subscribe my channel and turn on the notification bell. Give a thumbs up, comment and share.